So let's start with the agenda. We're going to cover today 6 things. First thing, lean, the cost reduction basis of lean and why it's so much more. Then we're going to move on to practical tips to find where and how to start reducing costs. Then actionable tips to engage your people in the fight. Getting help so that it's not just you or a single person, a specialist doing this. Then 17 practical steps to reduce your labor and materials cost. Then a case study that I did with a injection mold company. Here's the case study. Now, we'll get to this, don't worry. Before we get to this, and it will be practical, first of all, I want to give you a bit of background. So, Senpai, our business, it was formed in 2007 to help manufacturers who are serious about reducing their costs or improving their businesses. Very small to very large manufacturers. Our client roster is 2 million to 30 billion pound businesses. Fundamentally, we transfer true lean capability to the hidden heroes in manufacturing. I'm co-founder. My experience is with operations and lean manufacturing across 4 continents. I've worked with and trained and coached about 1,000 people in 100 companies. We generally do courses, coaching, and consultancy, and we have a number of things we do. You can see some of them here. I'm going to keep this punchy, don't worry. We work from shop floor to boardroom, all levels throughout the business. We have an award-winning lean app that we use to help people to improve their capability. Set up 2 global lean academies for billion-dollar businesses, and that's a picture of me in Japan with a team that was voted best factory after 5 years of lean transformation out of 170 factories around the world. I'm an awards judge, a conference speaker. There's my sensei from Toyota there who trained under Taiichi Ohno. Very savage man, but passes on a lot of knowledge. And I write a few books. Now, it's not allowing me to go on, but let's see what we can do here. There we go. Right. So I want to start with lean, first of all, and the background of lean, and go very quickly through this because I think we have to go back to roots on cost reduction because it can be misunderstood. On this graph here, money is the vertical axis there, and time is the horizontal axis. And in the cost plus environment, years ago, you'd have known that you added up all the cost of your product, your materials, your labor, your overheads, you banged on top your profit, and you said to the market, take it or leave it, that's the asking price. As we know, things changed. We're all in a cost down environment. And so the price is set not by us or by our quotation or our salespeople, it's set by the market now. And that every day of the week and twice on Sunday is going to be below what we want them to pay, which gives us a choice here, a palatable choice and an unpalatable choice. The unpalatable one is to reduce our profits, and we can't do that because our shareholders will cry and we can't reinvest in the business. So if we maintain our profits, we really have only one choice, and that's to reduce costs. Now, I appreciate that that may be preaching to the choir for some of you, but I firmly believe that if you're in manufacturing, everybody in your business should be able to sketch this out on the back of a napkin, because this is the fundamental reason why we have to pursue a lean path. But it's not the only reason. It's necessary, but it's insufficient. There is, of course, the lead time part of the equation. And the fact that, yes, it's about cost reduction, but it's also about lead time reduction. And the fact that whatever you make, somebody else makes something similar. And if they're able to offer half your lead time, 2 weeks rather than 4 weeks, they're likely to take your lunch off you. But beyond that, cost reduction gives you the base so that you can think about flowing value better. And my favorite definition of lean is the ability to be able to flow value to the customer using fewer resources. And that really connects us to the customer. But the start point is cost reduction, which is where we are today. Now, I'm going to spend the next 3 slides, and there's a bit of an example on here as well, talking about where and how to target in terms of cost reduction. The first one here is about the top level. The second one is going to be about what everybody in the business should be able to do and know and help you with. And the third level is operational cost reduction. At top level, my interest is in the 4 big loss drivers for any manufacturing business. Number 1, revenue loss from unhappy customers. Some of it you'll know about because they just won't renew contracts. Some of it you won't know about. They'll just go elsewhere. Number two, dealing with internal quality issues. Quality drives a ludicrous amount of cost within businesses. Number three, cash tied up as inventory. And number four, the poor use of capital, capital as in kit, machinery you invest in, having overcapacity on some things, which is sat idle, or monuments of capacity where you have large increments that aren't flexible if demand changes. And then there's the constant seeping loss of changeover for your productivity, for your OEE part of your operation. Those four big loss drivers, I think, speak to something really important. And manufacturing people, whether they're ops managers, ops directors, or CEOs, there needs to be a mindset shift. And the mindset is, yes, it's okay to think like a professional manager and have an ROI approach to the business, but also you need to think like an owner and have an ROA, return on assets versus return on investment. The top one there, your professional manager will be thinking, I've been brought into this business. I've got all sorts of problems. What sexy new technology or kit can I invest in to help me to become more productive? The bottom one there, the owner, and I'm encouraging you to think more like an owner, will be thinking, okay, I've already sunk a lot of money into this business and resources. Am I getting the best for my buck out of it? Where can I reduce waste, look for issues, and improve the performance on the assets I currently have? Now, that's critical because if you're in a position of authority and you're looking to improve your performance, I would urge you to be very, very tight on the justification for capital and expect a full understanding of the losses to the decimal point of the current kit you have. So that's top level, strategic level, if you like. All levels of the business, in my experience, need to understand the three types of cost. And we mentioned these a little bit ago. The question is, does everybody know? Now, we know that your costs are likely to be made up of materials, labor, and overhead. The question is, does everybody in your business know this? From the quality manager to the finance manager to HR to your operators to your team leader. Let's take a team leader example here. This person. Going to need to know two things. Firstly, what are the percentage splits between materials, labor, and overhead for your given products in your given market? Because then they'll always have in the front of their mind, what can I and what do I need to affect most to improve stuff? If it's heavy on materials, then they should be always thinking about materials. Same for labor. But then they should be thinking, and you can help them to understand, what can I control? So let's take our team leader here, example of him. On the materials front, he can control, right, how much am I ordering to keep the line stocked? How much inventory am I holding between stages on the line? How much buffer inventory have I got? How much scrap am I producing? On the labor front, he can be thinking and he can affect, right, possibly how many people I have online, definitely how productive they are and whether we're getting back from breaks or not and we're hitting hourly targets, but also things like, are we working overtime? On overheads, the team leader can start to think about things like oil consumption. Where am I losing oil? The amount of glasses and gloves I'm handing out, the small things, turning off fans and lights at the end of the shift, the small things that they can affect. So those three levels of cost give you a good idea of how to target and where to target throughout the business. Sorry, that's first two levels. The third level is the operational level. And this is where I didn't start with SQDCP because I wanted to think strategically first. And then I want you to think in terms of your cost makeup for your products. But operationally, particularly quality, delivery, and cost, some kind of pie and Pareto analysis. So this is a defect pie chart showing that 20% of what we make are defects. And then we know that our number one line for creating the most defects in the factory. And then we also know our number one product for creating defects or scrap on our number one line. That level of 80-20 thought and understanding where our specific biggest drivers are is useful because time is scarce to improve. Once you know that, and once you have a return on assets mindset, it then comes down to Can you see? Are you able to go to the point in the shot that you've identified and see? And a quick recap on the 7 wastes. And I want to show you an example of the power of finding small wastes and stacking them up. Before I do that, so you watch anybody working and you'll see 3 types of work. Value added, stuff that transforms the nature, shape, or characteristics of what someone's making or doing, the product. So they might be welding 2 parts together, they might be assembling 2 bits together, they might be painting something. Then there's non-value added. This is stuff that has to be done currently, but doesn't actually add value. So it's things like loading and unloading parts into jigs because parts can't fly. Then it's stuff like changeover of a machine from part A to part B because you can sell both, but you need to change the machine. And it's things like inspection. But then if it isn't value added, strictly speaking, changing the product, and if it isn't something that you absolutely have to do, then it has to be waste. And the definition of waste is 2 words, everything else. And that takes you, if you've forgotten or you don't know or you don't consider it, that takes you back to considering the 7 wastes, which is a bedrock of being able to see in the shop. Now, let me give you an example of that. When I set up JCB's Academy a few years ago now, we wanted to set up a lean academy that was actually a training academy plus had a real factory part to it so that people could apply what they learned in a real environment. So we had to pick a product, and this was an arm for a vibratory compactor. And this here is Jim. I videoed him doing a 19-minute assembly process. So this is when we first found this product. In the first 2 minutes, I found 24 wastes, and I just want to play you the first 40 seconds or so and just give you a feel for the kind of wastes I found and then show you where it led. So, oh, sorry, hang on. So, here he is wrapping up a plastic bag to put a piston in. And that piston, he's now going to put in the vise after he's wrapped it like that. He hasn't got any kind of jig to just slot it into. There's a quality risk of damaging that piston now, as well as the time it takes. He's got to tighten that vise up. He's now gone hunting for his drill, which is more precious seconds lost. And he's about to get his attachment, reach over there. He could have left that on. He's turning around. That's a waste to go and attach his airline. He's got to yank it out. And he's about to do an operation here that's interesting. He's actually about to change the insert inside this piston, which there's an argument, and we actually stopped doing it in the end. So that's a processing waste. And actually, as he's doing it, he's having to glue back in with Loctite it back in, if his Loctite works. In this case, his Loctite is clogged. So now he's got to go and get hold of a pin, and he's got to unclog his Loctite. And if you look down to the right-hand side while it was playing there, you'd have seen there was a pallet he could have tripped over. And right in front of him there's a cup, a coffee cup, mind, that has a pipe in he's going to use in a bit with oil in that he's softening up now. All of these are pretty small wastes, but within the 19 minutes, I found 91 wastes. With Jim and with the team leader, we categorize these short-term low cost, short-term high cost, etc. And we managed to reduce them, to eliminate them, change it around. And when we brought it into the academy, this operation, we got a 63% reduction in cycle time. My point being, don't sniff at what we've all learned years ago and we continue to practice or not practice. And that's the importance of going and seeing and finding the waste on the shop floor. Which takes us on to the next bit, getting help. In that normally that kind of activity is put in the hands of industrial engineers or the lean team. Fundamentally important thing in reducing your costs is engaging, if you have 100 people, 100 brains rather than just one. One of the biggest mistakes I see is relying on specialists alone. Let's take this type of approach. So imagine that as a business, you decide strategically you want to go north there in the direction of the grey arrow. That's the direction you want to go. Now imagine that you have people in the factory actually who are trying to improve things, but they're improving things in different directions. They're just trying to do some good wherever they see bad. You're going to get some improvement, but your overall motion is going to be slower than if you had everybody pointing the same way. My point being, it's not enough just to get people finding Kaizen. Even if you can get 100 or 10 people doing it, you need to give them a direction to go in. And there's the direction there. You'll move faster. Which takes us to the importance of the leader, which is creating or clarifying the crisis to rally around. So cost reduction, a crisis. Why should people get involved? Why should they feel the need to help? Years ago, my father gave me a book, 35 years ago, Zen in the Martial Arts. That's the actual battered cover of it. Lots of stories in it. This one particularly gives us the reason why that's important. Zen master walking with a student. Oh, hang on, I've got a question. Okay, thank you. Quite right, Eduardo. Zen master walking with a student. Oh, I've got to go back. Walking with a student, and they see a fox chasing a rabbit. The master says, according to the fable, the rabbit will get away. The student said, no, the fox is faster. But the rabbit will get away, insists the master. Students, why are you so certain? Because the fox is running for his dinner and the rabbit is running for his life. I love that phrase. If people believe that you as a collective in the business are running for your life, they are likely to run a better qualifying time. They will give a bit more if there's purpose. And I'm going to come on to 3 or 4 nice examples of how to create purpose and frame the crisis in a minute before I get on to the cost savings. This takes really on to Hoshin Kanri, sometimes called policy deployment, a strategy to improve. It's basically, you're busy enough trying to run the business. There's very little time to Kaizen or improve the business. So whatever time you have, best be focused on the vital few things. And Hoshin Kanri can make sure you have the vital few things, unless you overcomplicate it. And in manufacturing across the world, we've overcomplicated it, left, right, and center. What I mean by that is there's a Hoshin Kanri X matrix, cross matrix that's used. It can be valuable if you're a mature business, you're used to using it, fine. If it floats your boat. For a lot of businesses, it's too complicated, too unwieldy. Even if you have it on one piece of paper like this business, where it's nice and colorful, they've got safety, quality, delivery, cost, growth, and manufacturing or management systems on there. I had a long-running debate with the MD of this business saying, look, you've got 51 things on this sheet. You're thinking that more is more. If I keep putting things up there, if we throw enough mud at the wall and half of it sticks, we'll get half of it done. Well, actually, mine and most of the lean professions experience is that less is more. The real skill in Hoshin is deselection. Choose the vital few, 3, 4, 5 things to focus on that people can get some depth on and really make some progress. That's the skill. And when you do it, have something for the head, so a logical reason we need to improve quality by X or Y, but also have something for the heart. We need to connect those two things so that people want to go after it for a reason. And that reason quite often starts with WIIFM, what's in it for me? Particularly, and I'll give you a Chinese example in a minute, of a factory I was in, where you can connect the pain of the shop to the pain of the leadership and the business. By the way, if you want a simpler Hoshin Kanri process, go on our website and you'll find it there under Lean Resources. So before I get into the 17 steps and the case study, I want to go through simple is best again. And I want to give you some examples of setting the cost reduction task, getting the troops rallied around it. Now, this factory is an injection molding factory with some other processes as well, probably 4 factories in one actually. The point here is that bit of paper on the floor, which is actually a label. Now, the fundamental issue was that there was a bank of injection mold machines, up to 50 actually, and then there were 9 assembly lines that they were feeding, but there was a disconnect. The molders molded what they wanted to a push schedule, and the assembly lines took what they were taking to a customer manifest. And the intermediate stock was out of control, too big and too much of some, too little of others. We could have set the lean team and the ops team a target to, right, value stream map it, then look for where you can do a future state and you can put pull systems in. But actually, we didn't. The question that we decided to ask collectively, including the MD, was, what if we had no paper on the floor? What would that look like? And sent the team away to look at that and think about that in a catchball style. Now, what that does is it leads them to the same place, which is a place of, right, to do that, we need to have some kind of Kanban in place, some kind of pull system, but then we need to connect both parts of the factory. And it leads to the same point anyway. In a broadly similar fashion, same factory, you'll recognize same trolleys, they had a problem with quality where lots of little tabs were being snapped off of these molded cases. Tabs are important for securing them. You could put a Pareto, pie chart on Pareto in front of the molding people and say, can you improve that? Or you can say to them, how are you going to get to the point where there are no clips on the floor? And that sets them running again. It stops you specifying and dictating what to do and asks the question. Another example. This is my sensei, Moroka-san. This was in China, mobile phone factory. He spent 3 days with me walking the factory and with the team at different places, looking at pallet trucks and trying to improve pallet trucks. It took me a while to figure out why before I asked him. I didn't want to ask him too early. The reason being, when he first went in, he started as he always does in finished goods. And he saw in finished goods that there were pallets of finished goods, all the value added material and labor that had been fallen over in the warehouse. Now, that's a waste. He then noticed that the pallets were a bit battered. And he noticed that the pallet trucks weren't in good condition. They weren't responding well. They also were a bit battered. So his decision was to get everybody in the factory looking at pallet trucks to get quality sensitivity throughout the levels. He got the pallet trucks, he got them assessing them, he got them in, giving them a 5S home. We did some basic PM, TPM on them, and everybody started looking after pallet trucks so that they wouldn't damage pallets, so that we wouldn't damage parts. And that's also how he started to teach them about 5S and TPM. He went in a different way rather than telling them to do lean tools. Final one. Plymouth, I spent the best part of an hour putting this together and trying to persuade the MD of a medical business, medical syringes business, that if he carried on as he was going to run out of space because their capacity was going to run out. Oh, 1 sec. Because their capacity was going to run out. Now, he understood it intellectually. His eye didn't come alight. I didn't see a fire in him when I was explaining that, okay, you'll have current state, you'll get him by now. Extrapolated current state, you'll have tears. And then future state, hey, here's a smarter way of doing it. But when I took him for a walk in the factory and we started, and this is the molding area, there's a door there. You can't see it, it's behind those. There's a door that leads to the warehouse. Whenever they molded anything, 90% of the time they were taking the bag, the pallet of molded parts into the warehouse and storing it there. Because once again, there was a disconnect between the molding and what was being needed for the final stage of the process. As soon as I told him that every time you send a pallet through that door, you failed, you personally have failed because you're just building inventory and you'll have to build a bigger warehouse. He got it, the penny dropped. So framing as a story really helps. Now, I'm going to move on to the 17 steps now. But before I do, I'm going to pause. I'm going to stop sharing and I'm going to ask if there's any questions. In fact, no, I'll pause it there. If you have a question, please either put your hand up or put something in the chat, or by all means, come off the mute. Okay, there is a question. Okay, no problem. Thank you. Yeah, thank you, Eduardo. So, no questions? Okay, I'll crack on. Now, on to the 17 steps now. Before we do, a word about your finance team. If your finance team are happy and comfortable to look in the rearview mirror to give you the reports and data, lagging metrics, and to tell you how things went the last week or month, please expect more. I've worked in a couple of businesses where a really strong finance team are engaged in operations. They want to get out there, they want to see what's happening, and they can give really, really sound advice on where to focus, what to focus on, CapEx, stuff like that. So don't forget the finance team. Get them engaged if you can. Now the 17 steps. So we're back to materials and labor, two of the biggest cost areas. Here's the 8 ideas for labor, and here's the 9 ideas for materials. Fear not, I'm not going to go through those individually on this slide. That's there so that you can just see where they all are. What I am going to do is spend the next 3 or 4 minutes going through these and to give you an idea of what I mean by them. These will help you to save money. So on labor costs, the first one. Imagine you're a pigeon and you're flying in the rafters of your factory. Look down and look at where the density of labor is in your factory. And then start to focus there, particularly if labor cost is a large proportion of your overall costs. While you're up there, take a look at the amount of space that is given over to storage, inventory tied up as cash. Also, do you have any assembly lines, two of them lined side by side, where you've worked out you need 5.3 people running one and 6.3 running the other by calculation? That would make 11.6, but you have to man up at the moment with 13 across the two because you can't have 0.3 of a person. But you can have 5 people on one line, 6 on the other, and one shuttling between the two. If you arrange the work well, put some little Kanbans in or some little sub-assemblies, because 0.1 of a person is still one person. Do you have machine minders looking after each machine as a habit or as problems that you've forgotten to solve or you can't get round to? Anytime you have a machine minder, there is a very expensive cost there. And quite often it's because it's been accepted. Abnormal has become normal. Are you using operator time, waiting time while a machine is cycling? Can you use it for something else, something close by, another part of the process? And those 3, 2, 3, and 4, I'm going to use in the case study in a minute. Have you standardized or at least sized the line feeding work in your factory and ensured that forklifts don't ride around the warehouse and factory with empty forks? Forklift trucks, as well as being the thing most likely to hurt you in a factory, they are also a huge cost. Anytime you see empty forks, think Eddie Stobart. An Eddie Stobart lorry or a transport lorry will always be down in its arches. It won't go anywhere unless it had to drop off, unless it has a pickup. Very often walking around a factory, and I encourage you to look at this, forklift truck drivers, because they haven't been asked to do it a different way, will act like a taxi and not a bus, i.e. they're going out looking for a fare rather than a bus going around on a route picking up fares, which will be less costly. Which takes us into a deeper understanding of standardized work. You probably have some experience in type 1 standardized work where somebody is doing an operation, start, second, third, fourth, fifth element, and then they start from the beginning, making something. There is something called type 3 standardized work, which is for long cycle indirect work, where you can look at what a team leader or a setter or a materials feeder does, and you can find waste in that. Indirect labor cost is sometimes hidden. And have you standardized the regular planned downtime elements of the day? Your startup time, your 5S and TPM time. This is a commissioned IT card system I put in for a business across the factory where the small chunks of time needed to do things like 5S and TPM are standardized for a certain time and a certain length. And consider ways of using short periods of unplanned downtime to complete non-value added tasks. So you can have a rack where it says, if we have a 5-minute breakdown or a 10-minute changeover, please do this, this, and this. This one I would encourage you to do today or tomorrow. Shift changeover or the start of shift. Look at the shift changeover discipline. So if you have people drifting into their cells or drifting into the factory, bear in mind that if everybody starts at 3 when they should, or at 2 when they should, that's a lot more cost sensitive than if 100 people start 1 minute late. That's 100 minutes. You've lost an hour and 40 minutes of productive time there. Moving on, material cost. How well are you procuring material, and are you making the most of your negotiating power? We've always got to start there. How well are you negotiating? Look at old suppliers you've been with for a long time on old contracts. And then the yield and defects. Now, I'll come to that bin in a minute. I'd encourage you to do a Pareto of your high-cost material scrap types by quantity and cost, yield and scrap. You should make any scrap bins you have should be somewhere prominent in the factory, on a gangway facing outwards, no lid, not covered, and they should be small to fill quickly, especially if you have expensive exotic materials, if your material cost is high. And your engineer supervisor needs some basic problem solving skills. Is your make buy in good shape? Are you so vertically integrated as a business that you're doing some very basic things that just tie people up? Sometimes it's not worth doing it for you. But if you do outsource, remember the effect on contribution to fixed cost and profit. Number 4, how well are your materials planners bringing in material only when required, not before? Have they got used to bringing in stuff early because they don't want to get a shoeing, they don't want to get told off? Is there some noise in your production planning, information flow problems? Or are there production issues in certain parts of the factory that force frequent replanning? We're replanning multiple times a day. Have we got used to running with too much fat in goods inward stock? Again, Excel is your friend here. And then finally on these, how quickly you get a material through the business. Lean is about compressing the timeline as well as cost reduction. So where is inventory and cash therefore stagnating? And a rough cut value stream map helps. How smart are you in ensuring that incoming deliveries are optimized? This one, I often see a lot of potential. Use Excel again, bought out part numbers, multiply the cost per unit by the current inventory, add 2 columns on the end for the supplier location and the frequency of the inbound delivery, and then find those suppliers who are 10 miles away but are delivering fortnightly so that you're having to hold the inventory. How are you not communicating well with your suppliers? Where are you giving interface waste to your supply chain, either batching or you're just sending schedules late? Ask them where you're not helping. And finally, look at stock losses by part number by value. Overs and unders from stock takes to show possible BOM errors. There's nothing less interesting than a BOM error, but they drive a huge amount of waste throughout the business. Now, onto the case study. I'll pause this for a second. Has anybody got anything they want to ask me about or challenge? Okay. I'll keep going. So this case study was for a factory in the Midlands. Their focus was on labour and scrap cost saving. And it's actually mentioned in my book, Ventures in Leanland. Small client, £6 million turnover. Every penny counted at this point in their growth. Revenue growth and cost control to survive was their focus. They had a need to stabilize quality to get repeat business because they were letting themselves down. They weren't getting repeat business because of their quality. And we saved £50,000 in 1 hour and 17 minutes. And here is how we did it. Now, the case study I'm going to show you is based off the email I sent to the MD that afternoon. So I'm going to dissect that. Here's the thing. Anybody on this call today could have done this. It's basic industrial engineering, seeing, not just looking, and a bit of attention to detail, being willing to stand in the same spot for 5-10 minutes and look. The labor cost things I mentioned earlier, this is 2, 3, and 4 of those combined. So here's the email I sent him afterwards. Bullet point summary. I spent today looking at the mold shop, quick hit productivity to support labor cost reduction. I was there for an hour and a half and they were running what, 6, 8 machines or 7 machines. I focused on 4 machines, 3, 4, 6, and 7. And this is a reason why I focused on those 4 machines. Let's start with machines 3 and 4. I looked at them and a quick look showed that they were being man-marked, so 1 operator on each machine with a lot of idle time in between machine cycles. Semi-auto operation, each person had about 21 seconds of cyclical work plus 2 seconds of non-cyclical. Non-cyclical work is work they have to do every so often, like fetching empties or taking full pallets away or quality checks, where you time how long it takes to do that thing and then divide it by the frequency with which they do it. So 23 seconds in total. I set up a trial with the team leader to run both machines with 1 person walking between them for an hour. And we worked out get exactly the same output with 1 person as with 2. That's a saving of £600 plus per week by just not man-marking machines. However, at the moment, the boxes he uses to put the finished products in would need to be made up by the labourer. But my calculation, again, a bit of industrial engineering here, is that it'll be half an hour per shift for the labourer. And with some work on the bench size and orientation, they could maybe squeeze this into the operator's work as well without flogging James there to death. Turning the machine around would have been ideal, so that loading side was a loading side, but not possible at this point, too expensive. And as pointed out, they need to write an SOP for it. If leg ache is an issue because of the walking, that's why we tried it for an hour, then they could rotate every half a shift. And here's a video afterwards, just showing briefly. So this is the first machine. Take the part out, spark it off again. Then add a bit of packing. This is a dry verge that goes on the side of your house. Just clip off the sprue and then walk around to the next machine. It's a walk, but it's not that big a walk, and it's the lesser of 2 wastes. And he arrives just in time for the second part without rushing. Now on to machine 6. Machine 6, noticed the material was clear, a lot of scrap around the machine when I looked at it, suggested a quality issue. Looked at the cycle time, 46 seconds, and he only had 25 seconds of work content, but there were lots of spare parts hanging around, which set alarm bells ringing. I counted with him that he had 10 scrap out of 160 by 9 o'clock. That's a 6% scrap rate for damage to 1 hand. It was a 1+1 tool. Observing it, it looked to be after ejection, and either the part was dropping on other parts that are already there, or it was bouncing up and hitting the casting of the machine, because the team leader had made a shoot. I nipped out to home base to a DIY store, bought a net, tensioned it, put it under there. We very nearly eliminated it there and then, but then they eliminated it with tensioning it a bit more experiments. And that one saved £314 per run per week, 5,000 they ran at a time. And this next slide just shows you the maths there. The maths I put there because we have to know what the true costs are. In this case, it's the parts lost, but also the extra 4-hour run for the matching hand blanked off. Labor cost, etc. So, machine 7, final machine here. 2 people sat down. Looked like a simple job. I know foam has a knack to it. I couldn't see any real quality issues, and they were keeping up okay. It looked here like it was somebody who'd been trained and had got to it and had got to the training standard, but there were still 2 people on there. And they were concerned about a persistent scrap issue. So my point was, get your best tech focused on that. And then you can speed the machine back up to 40 seconds from 48, and you get a 17% productivity boost. So that all added up to £50,000 in 1 hour and 17 minutes. Now, almost done now. In this session, we've covered 6 things, these 6 things. Well, 5 of them so far. What I want to do is just take a couple of minutes before I do Q&A, excuse me, and tell you about the trickier bit behind this, the bit I left them with. So actually being able to do all that does take some training and some skill. The trickier bit was leaving the 4 things, setting the 4 next most useful things that factory could do. And they were having defect bins at the end of each shift in a home. Making sure that the team leader and the ops manager picked a random part once a day from a red bin and asked the operator, why is it in there? Just to test the understanding of the quality standard, because good parts were going in the bin, to clarify whether the standard's weak or people are putting good parts in the bin by accident. Third one was put hourly boards on every machine so that we can track on an hourly basis rather than managing by day buckets, it's by hourly buckets. And the fourth one was getting the best set of troubleshooting in a couple of hours overtime a day, because he wanted it, the top 2 scrap cost part issues.